This lesson is on solving multi-step equations. We'll be solving multi-step equations and we'll be justifying the steps when solving those equations. We'll be using a new property today called the substitution property. Sometimes the substitution property is confused with the addition or subtraction property. So if you recall, the addition property is if A equals B, then A plus C equals B plus C. And the subtraction property is if A equals B, then A minus C equals B minus C. In both instances, we are adding or subtracting to both sides of the equation. When we use the substitution property, we use the substitution property when we're combining like terms. We're just manipulating numbers on one side of the equation. So what does that look like? Here's an example. 5 equals 5m minus 23 plus 2m. The first step in solving this multi-step equation is to combine like terms, adding the 5m and the 2m together, which would give us 7m. The justification for that step is the substitution property, not the addition property. That is because we added 5m and 2m together on one side, and we substituted 7m for 5m plus 2m. The next step in this equation is to add 23 to both sides. That would give us 28 equals 7m. That is an example of the addition property of equality because we added something to both sides of the equation. All right? So the difference between the addition and subtraction property and the substitution property is that the substitution property is when we combine like terms, when we manipulate numbers on just one side of the equation. So I'd like you to find your notes on properties and add the substitution property. This is what your notes on properties look like. There were some tables. And if you could squeeze this part about substitution after the distributive property, that would be a good place. If not, anywhere it would fit, but I want this also written in the part of your notes about properties. So go ahead and take a moment and copy that down. All right, solving multi-step equations. When we solve multi-step equations, we will come across the distributive property. We'll be using the distributive property and the substitution property, or when we combine like terms. So our first example, 6p minus 2 minus 3p equals 16. The first step in solving this multi-step equation is to combine like terms. 6p minus 3p is 3p. So we can rewrite it as 3p minus 2 equals 16. So we combine like terms. We took 6p minus 3p and we substituted 3p for that. So we use that substitution property. The next step to solve this multi-step equation is to add 2 to both sides. All right, so for going from 3p minus 2 equals 16 to 3p equals 18, we use the addition property of equality. And our final step is to divide each side by 3. So we use the division property of equality. So that's how you solve a multi-step equation and justify your steps. Just writing what property you used. Next equation, number 2, negative 8 times the quantity 2x minus 1 equals 36. So the first step here is to distribute the 8. So negative 8 times 2x is negative 16x. And negative 8 times negative 1 is positive 8. So the property we used to justify that step was the distributive property. And we continue. Subtracting 8 on both sides. So we use the subtraction property because we subtracted on both sides. Oops, I've got my x here. And now we're going to divide by negative 16. And x equals 28 to negative 16ths. Okay, so first let's go back and say that was the division property. We'll squeeze that in there. Alright, so we should always simplify our fractions. So 4 goes into both of those. So my answer is 7 over negative 4. I could also write this as negative 7 over 4. And I can also write it as the negative in front of the 7/4. So all three of these, the negative in the denominator, the negative in the numerator, and the negative in front of the fraction, they all mean the same thing. Okay, number 3. We are going to distribute. We have 8n minus the quantity 2n minus 3 equals 12. So we're minusing this 2n minus 3. So in essence, we are distributing a negative 1. So we're going to multiply what's in here by a negative, so everyone's sign will change. So 8n minus 2n plus 3 equals 12. We're minusing this, so this has to be the opposite. If we were just adding this, we wouldn't need the parentheses, but we're subtracting it. So think of it as multiplying by a negative 1, so you have to distribute the negative 1 or change the signs. All right, so that was an example of the distributive property. Now we're going to combine 8n and 2n and get 6n. So I'm substituting 6n for 8n minus 2n. I'll now continue by subtracting 3 on both sides. So that's an example of the subtraction property. And now I'm dividing by 6. So that is the division property. So n equals 9/6. So we can keep it in an improper fraction, but we certainly want to reduce that. So 3 goes into both of those. So 3/2 would be your answer. Number 4, 5y minus 3/5 equals 4/5. So here we are with a fraction. So this is really maybe more of a two-step, but it's a fraction here. So we want 5y by itself. So we're going to add 3/5 to both sides. So 4/5 plus 3/5 is 7/5. Okay. So we use the addition property. And we were able to add those fractions together. Remember, when you add or subtract fractions, you must have the same denominator. We lucked out here. So now we have 5y equals 7/5. So 5 is divided by y. 5 is multiplied by y. So we're going to divide each side. Let me get a different color here. We're going to divide each side by 5. So 5y divided by 5 is y. 7/5 divided by 5. Well, let's think. We could write that as 7/5 divided by 5. When we divide a fraction, we can say it's divided by 5 over 1. We multiply by the reciprocal. So 7/25. So let's check this one. Get a different color here. All right, we're going to check. We're going to say 5 times 7/25 minus 3/5 equals 4/5. So here we can just cancel that out, reduce that, and now I have 7/5 minus 3/5 equal, that's a, oh my goodness, that's a 5, equals 4/5. And 4/5 equals 4/5 equal 4/5. So it checks. And those are just a few examples of how to solve multi-step equations and justify your steps.